Can I go on a slight side rant about naming a mission Lunar Trailblazer in the year 2022/2023 more than 50 years after people have literally walked on the moon? It's like we've already kind of blazed that trail. You know what I'm saying? It's like the moon is like been there. There's a lot to do. I'm not denying that. I'm not denying there's a lot of new stuff to do at the moon. But it's like Trailblazer is kind of like, that's the name of a mission when you're going someplace the first time, not the like 97th time. Welcome to Walkabout the Galaxy, the indestructible astronomy podcast where the science is universal, the opinions are personal, and the hosts are hurricane weary. We are Strange Charm and Up the Astroquarks, also known as Josh Caldwell,
Addie Dove, and Hannah Sargent.
Coming to you from the Walkabout studio at the University of Central Florida. Remember to subscribe to us on all platforms, including YouTube, Facebook, Twitter, and Instagram, but not Discord, Tumblr, Snapchat, or Reddit.
Or Mastodon.
Is that a thing?
Yes. It is. That's the one a lot of people are switching to.
I was trying to see what are the hot new social media platforms, because it seems like there's a new one every 6 months or so.
Yeah.
That somehow a billion people all of a sudden switch to something, and then it's like, I'm on that. I'm on Mastodon.
This is the mass exodus from Twitter. So Mastodon is
Twitter-like?
Is potentially going
to be more. It's not really Twitter-like, but it's potentially going to be more popular. I think a lot of nerds are on it.
I see.
Yeah, there's a lot of
more of a nerdy platform, I think.
I see. Okay, well maybe we should be on Mastodon.
I know.
I'll have to check it out.
I don't know what that means.
We are, however, at walkaboutthegalaxy.com. You can contact us anytime by emailing wtg@ucf.edu, and do contact us that way if you'd like to order a Walkabout the Galaxy shirt like this, so we can get it to you as soon as possible. On our last episode, we recognized the winner of our last t-shirt giveaway, Trey Harmon from California, who was closest to what will turn out to be the correct answer. We don't know what that correct answer is yet, but it's either going to be 0 or 1.
In binary?
Yes.
On or off?
I think his guess was 2.
I thought it was 3.
Was it 3?
I don't know.
It was 2 or 3. In any event, it was the lowest guess we received, and the true answer is going to be 0 or 1. Which was, how many super heavy orbital starship launches will there be in 2022?
Yeah, we had high hopes at the beginning of the year.
Yes.
High hopes.
And now they've been dashed.
Yes. Mm-hmm. There is still some muttering about a potential December launch.
There's been an announcement-y type thing about a December launch. Yeah.
And this is it. NASA has a stake in this because this is a necessary step for the lunar landing of astronauts.
Yeah.
So it's kind of like, it's not just Elon Musk and SpaceX trying to colonize Mars activity. It's a contracted obligation.
Yeah, unfortunately we have to care about this one.
If we care about the lunar enterprise.
Yes, then I have to,
In any event, though, our Stumper today is a legitimate, meaningful question.
Oh.
What should
I mean, they mostly are.
Not. What should our next listener contest be?
So I was trying to think of, guess the date of when something might happen.
Okay.
So I was looking at what
get closest.
Yeah, so I was looking at what projected launches there were going to be next year, and I saw. Do you remember the Dear Moon project? This.
That's a SpaceX thing, also, right?
Yeah, and
that's for the Japanese artist billionaire.
That's the one, and sending other artists with them.
Does that rely on super heavy?
It does.
Yeah, I think so.
But from what I understand of it, it is postponed. There's no information on. There've been no updates for a long time. So I was looking at other missions. The only one I can think of is Trailblazer, set for 23.
Trailblazer,
yes.
Then, and I know they've had
that
some.
Sounds like an SUV.
Lunar Trailblazer.
Lunar Trailblazer.
Okay.
It's launching now with IPEX, or it was supposed to launch with IPEX, and now it's not.
It was.
What's IPEX?
Or Intuitive Machines.
What's Intuitive Machines?
Okay.
No.
So the spacecraft will launch in the middle of 23 as a secondary payload on the Falcon 9 of the Intuitive Machines 2 lunar lander.
Yeah, so that's updated. So originally, Trailblazer, which is a small lunar mission.
Small lunar mission. Is it going to land on the moon or orbit the moon?
It's an orbiter.
Okay. It seems like Can I go on a
Lunar
slight side rant about naming a mission Lunar Trailblazer in the year 2022/2023 more than 50 years after people have literally walked on the moon? It's like we've already kind of blazed that trail. You know what I'm saying? It's like the moon is like been there. There's a lot to do. I'm not denying that. I'm not denying there's a lot of new stuff to do at the moon. I'm very excited to see what your mission, Addie, is going to be seeing at the Gruithuisen domes, domes on the surface of the moon. But it's like Trailblazer is kind of like, that's the name of a mission when you're going someplace the first time, not the like 97th time. Note to self, great trivia question, how many missions have we had to the moon? Have we already done that
a
trivia
mission
question?
like that. We've done
A question
a
like
question like
Yeah.
that. Yeah.
But we don't remember
I will
the
say,
answer though.
so Trailblazer is a simplex mission. And so it's a small CubeSat-y, small mission.
Right.
And
Maybe
it will be, the idea is that it'll be doing trailblazing measurements about like lunar water and volatiles and stuff like that. So.
Okay.
And it's a super cool little mission.
Maybe the trail they're blazing is more technological or
Carrie
something like
Donalds
that.
and Hannah and others here at UCF are
Yes.
members of Team Trailblazer. Also.
I was aware that she was, others
Students.
are too. Students,
Yeah.
okay. Yeah.
But yeah, and from what I understand of it, they've had some some significant cost overruns and some delays and things. So it was just more.
So that's the best you
it's
come up with.
because
Is like,
it's
when is Trailblazer going to
because it's got
launch?
some volatility
Which
to
has
it.
an announced date
It's
of
mid
mid-2023.
23. That
I think we
that's-
could broaden that though
Yeah.
to more of a like how many lunar landing or lunar
Lunar
missions
missions.
will there be
Yeah.
in 2023?
Oh, I like
Yeah.
that
And
one.
like we could do a couple categories and or one broad category of just like how many missions will actually launch, how many will succeed, like get to where they're trying to go.
Oh, we're going to do
Total-
another
total?
multi-part question.
It could be a it could be a classic multi-part
Total.
question.
I only got so many shirts to give
Oh, that's
away
true.
here,
That's
but
true.
yeah,
Okay,
okay.
so
Could be something along
there's
those
good
I like
themes.
this idea.
Yeah.
We'll work on this and post
I
details.
was thinking something I was originally thinking something else, which was something like, how many times do we say certain words or something like that?
Oh, no, because
that's
during the
doable.
year.
That's a doable thing.
Someone will have to monitor that though.
Oh, I'm sure
It's
somebody
doable.
would.
It's doable.
Logan, sorry.
Yeah. Yeah.
That
Now
kind
there's
of thing could be
software for
funny,
that.
too. That's
There's
true.
software for that, and we
That's
could
true.
do it when we use certain recording software. It provides an automated transcript of what we say, which is a little embarrassing.
Yeah, something like that could be amusing too. More podcast
How
focused.
many times
Do we
does
say-
Josh interrupt you?
Sure. How many times does Addie say moon?
Right. How many? You're right. Yes.
Those
Right.
kinds of things.
Okay.
But I like our lunar. I mean, I think for us and for upcoming space events, it makes sense to do a how many moon missions question.
Okay, I like it.
We'll format it better and have it available for you, dear listeners.
Yeah, this was
in
our
last episode of this
brainstorming.
year.
Okay. Well, today we'll talk about asteroid threats, cosmic neutrinos, and maybe other stuff
Oh.
that I don't even know about yet.
Perfect.
Because I'm going to find out about it
Oh,
from the two of you.
Excellent.
Yep.
But first, this episode of Walkabout the Galaxy is brought to you by Olympus Mons.
Ooh.
Set your vacation destination to the tallest mountain in the solar system, more than twice the height of Everest and covering an area as large as Poland. Random.
Nice.
We recommend a rover for your trek to the summit of this long extinct volcano. With its shallow flanks, you can stop to enjoy hikes across the dusty Martian surface. Take advantage of Mars's weak gravity to rappel into the 6 large calderas at the summit, then return to base camp for a well-deserved gourmet meal and spa treatment at the luxurious Olympus Resort. Olympus Mons, your vision, our future.
Ooh. Your vision.
That's sort of inspired by White Lotus.
Oh, I haven't watched that.
I didn't know what that is.
It's an
television
HBO
program.
series about swanky resorts. So it's like imagining a swanky resort at Olympus Mons.
Oh, yeah.
The one they're at now is in Sicily, which is maybe a little bit nicer equipped than the one at Olympus Mons.
I have no idea about the sponsor, but I was really excited. No, I was really excited that I knew what Olympus Mons was and I could interpret everything that you were saying until the tagline at the end. Then I've got no idea.
What is it?
I'll give you a hint. It's one you should be able to figure out.
Oh, thanks.
Your vision, our
Your
future.
Vision. I'm trying to decide if it's like a resorty type thing or like a glasses company.
I'll give you another hint. It is neither.
Oh, okay. Your vision.
It's
our
it's
future.
closer to glasses though.
Okay. Okay.
Is it like VR?
Yeah, is
No.
it? Okay. Oh man, we're striking out today.
Yeah.
Yeah.
I'm gonna go with.
I give you another hint is I was not clever at all.
Burj
coming up
Khalifa.
with this. What?
The tallest
Burj Khalifa?
the
Tallest building.
building. I was thinking biggest mountain,
Oh,
tallest
no.
building, new
I like
new
it.
Give
design.
you another hint. Olympus Mons.
Is it a
Olympics.
watch company? Is it
Olympus.
Olympus? Olympus
The
is a
camera.
company.
It's a
Oh.
Camera company. That's it.
Oh.
That's it. Yeah.
Olympus cameras. Yeah.
Nice.
Okay.
Wow, that was painful.
That was
That was
painful.
painful for
Sorry.
everybody involved, including our listeners.
Dear
Yeah.
listeners, who are shouting
I
at
hope
us
so.
that
Yeah.
whole time.
Space news.
Space news.
Well, you have already mentioned hurricane.
Yeah, I was kind of amazed.
Oh, man.
So we're recording this shortly after our second
The day after.
hurricane sort of passed through the area. So we had Hurricane
TS.
Ian,
Yeah.
and this one was, they're not hurricane force when they make it into Orlando, but
Especially
still
not this one.
It was
Big
pretty
storm.
breezy still.
It was
Yeah.
breezy.
pretty
overnight.
breezy. Not as much water as Ian,
Mhm.
but this was Tropical Storm Nicole by the time it was crossing across the
And
state.
Nicole really did aim for Kennedy.
And it basically made landfall at
Just south of Kennedy. But
Yeah.
I meant a lot of the really nasty stuff on the north part was,
was
hitting Kennedy.
yeah.
Yeah.
And they had rolled out the Artemis SLS
SLS.
launch vehicle.
Because they were supposed to launch on Monday,
This
and the
coming Monday.
hurricane hit Thursday before.
So like last
Yeah.
week they rolled it out,
yeah.
and then like 2 days later there's like, there's
Oh.
a storm coming.
Yeah.
So I was wondering.
And it's sort of like a big deal to move it back and forth. Like that
Mhm.
produces its own stresses on
It
things.
does.
yeah,
Because
because
last time they rolled it back, they said, like, we
We
only
don't
want
wanna
to do
do
this
this.
a couple more times.
Right.
And make
there are
maximum.
limits. Because I was trying to understand why they didn't. Why is it so bad to roll it back? And they said they're only designed. It like wears them down basically, and they can only withstand so much of that.
Because it's
movement.
different types of like stress where they're attached to,
Yeah.
to the
Mhm.
thing
It's-
that's transporting it, and
it's
it's
a-
like the crawler has its own
Bouncing
vibrations.
and
Yeah.
things,
and
and it's
stuff
like
like
a
that.
giant building set on top of a platform that's rolling, and it's
Swaying
And
and
it's-
yeah.
But the winds that hit were above what
Well-
Artemis is designed for.
Oh,
And that was
gosh.
scary. But apparently, visually, it looks okay, and they're
it didn't
sending.
crumple and fall apart.
Yeah, there wasn't an explosion.
I have to say I was having a lot of like sympathetic empathy for the
The
NASA
rocket.
people
Oh yeah.
who
Yeah.
were making these calls.
I know. Yeah.
About like first they roll it out and then there's a hurricane coming and it's like, oh crap, what do we do? Do we
Yeah.
roll it back? And they're like, well, the forecast looks like it's going to be well south
Uh-huh.
of us. Should be okay.
That's
And
worked out
then,
well so far this year.
Boy,
Yeah.
it was
It was
like,
further
oh,
south
man.
than one of the tracks had it basically making landfall with the eye
Oh,
like
I-
at
Over the
Pad
rocket.
39
yeah,
area.
yeah. But fortunately, yeah. So this Artemis, so it was a hurricane magnet.
Yeah.
This
Oh,
SLS,
that's
because
not
it had
a
rolled
good
back
omen.
last time because of a hurricane. It was
That's
really
right.
good they did that time.
Yeah.
Because I
Yeah.
think the winds were actually higher last time.
Yeah.
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 But so they're still aiming. So they're obviously not going for Monday, but they're still going to try for Wednesday.
They're assessing today
Yeah.
what the damage
Next
is.
week.
Yeah.
I think there's some minimal damage, but hopefully not.
Okay. Well, I know, Hannah, you're very anxiously awaiting this launch because your
I'm-
days here
Are numbered.
in the Sunshine State are numbered, sadly, to a not a huge number.
Yeah.
They're
Just a few
numbered,
numbers.
just numbers we can count on
Yeah,
digits.
Yeah,
Accountable-
well, I'm running out
accountable
of Artemis launch windows, put it that way.
Right.
Yeah.
Right. Yeah, which means we're also, sadly, we're running out of Walkabout the Galaxy recording sessions with you.
Yeah. So,
We'll have to
So-
do. We'll
could we do a British
potentially-
theme session? British themed
Well, maybe
Sure.
we'll.
recording?
If you
When you-
buy some equipment, we'll come over and visit, and we can record it at your place.
Yeah.
That'll be great. Okay.
Walkabout goes to
Walkabout,
Walkabout
goes to
on tour.
England. Yeah,
Yeah,
Walkabout on
walkabouts.
tour.
Exactly.
Yes. Note to listeners in wonderful places to visit.
Yeah.
We're ready.
We'll be there.
Any other Artemis-related space news? So we're just waiting the launch there.
Just awaiting. Yeah.
Yeah.
Anything else?
There
We
is
sh-
another launch happening from the Cape also this month. That's another set of planetary missions.
A launch with a set of planetary missions on board.
Yeah, I'm
Efficiency.
phrasing it
nice.
really bad.
and also it's like completely off my radar.
It's a SpaceX launch that's launching. Why am I so blanking right now?
Maybe
know.
we'll come back. We'll come back to this. All right. Yeah, I don't know what these are.
Yeah. Well, we should start with our solar system science, and then our trivia will be a transition to our cosmological science, because the trivia is related to our final story about neutrinos.
Okay. Oh no. No,
you're less
this
excited
is
about
a
that.
disaster. Yeah, this cannot go well. Speaking of disasters, the trivia,
yes.
But disasters.
Every time you say that, you win.
Oh, it is for flashlight. Why am I being so dense? It's for
I don't know.
flashlight, which is a different lunar mission.
We totally had moved on. We don't even know what we're talking about anymore.
This is the launch on it's currently slated for November 22nd.
So what's flashlight?
So lunar flashlight is another one of these like little tiny CubeSat-y type things. Do you have something to say about it?
I know. I'm excited about this one.
You should be, yeah.
Because basically they're going to look inside the shadowed craters in the poles, which we've only been able to.
With shining a flashlight down there?
That's kind of the theme
basically.
of the name.
It's an IR laser. So they're going to shine lasers and look at reflected light. And
What sounds do lasers make, Addie?
pew pew.
Thank
But
you.
IR ones, I think, are like pew pew.
Ooh, ooh.
Yeah. They're lower
They're lower frequency.
Oh dear. Yes.
Ooh.
But it's a really exciting mission. I've been waiting for this for a long time, because a few years ago, I was doing some research trying to process some images to try and understand or look inside these permanently shadowed craters, and everyone was saying, oh, but when flashlight launches, this will like revolutionize this.
Okay, so do they have an IR camera then, I assume?
Yes.
Okay.
They have an onboard spectrometer, and they fire infrared lasers to map ice, and they're trying to look in the permanently shadowed craters of the moon.
That's
Okay.
where we hope the ice is.
Okay.
Yes.
Great.
So,
Cool. All right.
Yeah.
So that's coming up.
It's a ride
weeks.
share with another
Ride share.
main
It's
launch.
like
So
like
it's
a
a
SpaceX
SpaceX launch. And I
Space
don't
Uber.
remember. Yeah,
Yeah.
exactly. I don't remember what else is launching on that.
I think you
rocket.
can actually, on the Uber app, you can select the moon as one of your destinations if you're doing a share, like a pool.
Sure.
You know, Uber pool to the moon.
It doesn't give you an estimated arrival time yet for your ride, though.
No.
Can I put that on my credit card?
Yes.
Your asteroid news.
Asteroid news. Okay. So we've talked a few times now about this DART mission and this trying to deflect an asteroid and see if we can meaningfully change the
And we did.
orbit, and we did.
Surprisingly successfully.
Yeah.
Yes.
But there are many more steps involved in protecting our planet from potential asteroid impacts. It's not just can we deflect it, whatever else. It's all of the possible things that could happen here on Earth, and we need to practice those scenarios. And so there's been
Disaster planning.
and there's been an exercise this year with a hypothetical asteroid impact.
So they do this almost every year now, I think.
Is it
right?
every year?
This
They do
drill.
it periodically, yeah. And
Does the exercise involve mass panic in the breakdown of civilization?
Yeah.
Where are they holding these exercises?
It's simulated.
Maybe
mass
this is
panic.
explaining what I've been seeing outside.
Yeah.
No.
So
No.
this is the fourth planetary defense tabletop exercise. So it's run by NASA's Planetary Defense Coordination Office, and it involves like government officials on all different levels, scientists and so on, and they basically present this scenario where there's an asteroid striking or on its way. It's been detected very late. It's going to be here in a matter of weeks or whatever. So you can't design a mission and launch it and whatever in advance. So it's kind of what happens next. And it's just really interesting.
Bad things.
Yeah. And one of the things that was interesting,
It's a bit of a Kobayashi Maru too.
It is.
You're not intended to win it.
Yes.
Right. How do you handle
How
the
do you handle
no-win
the
scenario?
no-win scenario?
Yeah, they designed the scenario so as if it was going to pass through all of the gaps in the current planetary defense, like.
The gaps in the current planetary defense? Is there a planetary defense
Well, there's
that
like
I
our
don't know
detection
about?
networks and stuff like that.
As in the current plans, or like we do, for example, we can't detect everything, so
Okay, so the detection. But it's not like, I just want to clarify that we don't have this
We don't
like
currently have a network.
armada of thingies.
No,
that
I'm
will,
talking in terms of the response, the people and the actions that they are instructed to do, that the plans that the White House has for disseminating information to the right people.
Yeah, I understand what you're saying about it. I just want when you say pass through the gaps in the planetary defense, it
not
sort of
in-
makes it sound like there's this beautiful shield up there
Not
that
yet.
is actually just
Not
working
yet.
to shoot down asteroids, but it has a few gaps, and this is coming through.
Right.
No,
Yeah,
there is
no.
no shield.
No,
No,
not
we
yet.
don't have a
gap is
shield.
the size of
That
the planet.
is fake news, which we will come into actually.
Oh.
The one of the solutions that they gave them, almost like as a last ditch hope, they said that in this scenario they have access to some nukes that they could strike as if once the asteroid was kind of approaching the upper atmosphere.
Boy.
Yeah, as
Yeah.
a last ditch attempt. And it kind of to demonstrate. Hold on.
Okay.
To demonstrate that it is a terrible idea. So
Okay.
if you have that option available, it doesn't mean that you should do it.
I see.
So it's trying to help them work through that scenario and show that actually that probably would be very, very bad.
So the purpose of this was sort of like to create a study so that if we got to this point in 10 years or something, it could be presented to a politician and say, no, we studied that. You do not want
you
to
do not
launch
want to
those
do that,
nukes.
right?
Yeah.
Exactly.
Because otherwise they wouldn't believe you if you just explained it to them.
Yeah, and it was kind of to demonstrate that yes, you might see this kind of stuff in Hollywood and in movies,
Yes,
but that doesn't mean it's the right decision to make in reality.
That's right. So the most famous mistake in Deep Impact, which I will say is famous for being a very scientifically solid movie about this
They
particular
had an
topic.
okay science advisor on it.
Oh, I don't know.
Oh.
But they blow up an asteroid, a comet fragment with
Yeah.
nukes shortly before it
Yes.
hits the Earth, and this saves the day, more or less.
Mm-hmm.
But if it's like right before, it doesn't make any difference
Yeah.
whatsoever.
'Cause
all that stuff
All that
is still
material
coming
is still
in.
going to
Yeah.
be on
You
its
have
way.
the same amount of energy
It won't
delivery
hit
to the
in one
planet.
location. It'll hit
It's
in
just-
multiple locations,
Yes.
but still have all
You
that
still
energy.
have all that kinetic
Yeah.
energy coming in. So,
So,
so using a nuke as it enters the atmosphere
not a
is
great
just
idea.
not going to do any good.
and then they also look at what would the evacuation exercise be? Because they've targeted this this hypothetical impact in Winston-Salem in North Carolina, I believe. So they had to design or suggest evacuation plans, but then they also added into the scenario this time this spread of misinformation and the impact of that.
How very 2022.
Yeah,
Yes.
and how to what works, what doesn't, and they said 20% of people. They were told that 20% of people didn't evacuate. They didn't believe it. Blah blah blah.
I would say that's an
Yeah, that's an
optimistically low
optimistic.
number.
Yeah, exactly.
So that was
that's
super
true.
interesting. And then also having people claim to be experts that this asteroid impact will bring with it extraterrestrial like biological material that's going to
it's
infect,
poison everybody.
poison
Oh,
everyone.
that's a fun one.
And yeah, it was just super interesting. And then seeing how they would overcome it, and I think they
When
did
does the-
pretty good.
When does the movie come out?
What was it? Don't look up. Yeah.
Yes.
So yeah, I just thought it was a really interesting kind of
Right. Yeah. Aiming
approach
out.
to planetary
So are we in good
defense.
shape now that we've done this?
We know what shape we're in a little bit better, I think, is
Maybe,
the
yeah.
Yeah, I think it's just preparing people for all these potential scenarios that aren't just the asteroid itself, but kind of the social impacts as well. But realistically, you need 10 years and ideally 30.
You need 10 years,
ideally
30.
ideally 30.
Yeah.
To do the whole, get
The
rid of it.
planning, and we're really going to make sure it doesn't hit.
Yeah.
Yeah.
Yeah. Ideally 30. Well, we'll have that for really big ones.
Yeah. Yeah, that's
That'll be.
and this was like a smallish one in the
Yeah.
simulation. So it was gonna cause damage, but it wasn't like a planet killer, I think. And so and those are the ones that are gonna be really hard.
Those are
to
the
see.
ones that are going to get
like
through.
even with our existing detection
Right.
network,
Right.
those are the ones that are gonna be really hard to get through. Or
Yeah.
that are gonna get through, gonna be really hard
And
to
speaking
detect.
of which, they've thrown, I think in the latest budget, they got this planetary defense program or whatever, were awarded like 55 million more than they asked
wow.
to try and help
Okay.
Yeah.
with all of this.
So maybe something like Arecibo would help with that.
Yeah. Do you want to talk about Arecibo now, or do you want to save it?
Do you want me to? Do you want to do trivia?
I kind of want to do trivia,
Okay,
and
well-
then our cosmological, and we'll look back to Arecibo.
Oh,
Or do you want to do...
I think so.
Do it.
I was going to say that's a very natural segue to talking
Okay.
about a recent paper that came out about
Okay.
from Arecibo observations of asteroids. So Arecibo has actually been pretty critical in a lot of our detection of near-Earth asteroids and other asteroids in the main belt in recent years, because it can do these broad surveys and sort of find characteristics of asteroids. And so there was a cool paper that came out a little bit ago, just a month or so ago, that was a summary basically of radar observations of near-Earth asteroids that had been taken. The observations were taken between 2017 and 2019, so for about 2 years of observations. And it was basically just that they were able to observe and detect 191 near-Earth asteroids. And they get a lot of really important information that's important for planetary defense, right? So not only detecting that something is coming at you, but how big is it?
Right.
Hopefully understanding a little bit about the materials, so that you can get some from radar data by looking at what's called the polarization and some of the light curves that come back. And some of their albedos, how bright they are, how fast they're spinning, how big they are. So you can get a lot of that information with Arecibo radar data. And they found a few that they were actually able to get better ideas of the shape. They found a few binary asteroids. Mm-hmm. One was an equal mass binary asteroid, so the two members were the same mass. And a few contact binaries. So those are things where they're actually making contact, but they're spinning together. Mm-hmm. So they're like probably not actually one thing, but they sort of act like one object.
Super cool.
Yeah. And they also found a couple of asteroids that were potentially metal rich based on their unusually high albedos. So we've talked a little bit about like the Psyche mission, which is, that'd be a good one for our... for a trivia. For when that one's going. The two that were metal rich, and so Psyche is going to a metal rich asteroid, and there's a few others out there. So
big difference deflecting a carbonaceous chondritic asteroid compared to a metallic asteroid, and I would imagine that also if you're looking at a binary or a contact binary and you're looking at deflecting that's going to be
it's like
a
playing
whole
billiards in
different.
space.
I don't want to see them do their role-playing game tabletop simulation with one of those.
The binary,
because that was actually because then one of the other things from that I guess exercise, they didn't know what the composition was. That was the point. So that the unknown and what complexities that adds to your approach.
Because if you have a contact binary, the dynamics of breaking that up is super complicated. Yeah.
So you need to.
And like a dart on that, would it break it apart, one of them would then be out of the way, or would it cause it to spin up more? Would it cause it to?
If you just have a single thing, you just want to deflect the center of mass of the thing because the thing goes with the center of mass.
Yeah.
But if you've got a binary or contact binary, deflect the center of mass, you could still have one of those things on a collision course to hit you.
Yeah.
I suggest we move Earth's orbit.
Move Earth's
we all jump
orbit
at the
to
same
that
time.
safe place
Where
where there's no
asteroids.
asteroids.
Right. Yes.
Okay.
Yeah.
Well, we're going to talk about in our next cosmological thing other things that are hitting us all the time, which are neutrinos.
Ouch. Ouch.
So we all know about the cosmic microwave background, right?
CMB.
Yeah.
Good job.
Good for you. This is
that wasn't patronizing at all.
You said it like
good job.
You said the way you said it though.
I was proud of myself.
That's the light emitted by matter when the universe first became transparent to light after the Big Bang, which was about 380,000 years after the Big Bang. That number is going to be important for the trivia. Okay. So
380,000
you have the Big
years
Bang, the
after
universe
the
is
Big
very
Bang.
dense, all this charged particles, stuff like that. Light can't go anywhere. It's just constantly being scattered, reabsorbed, re-emitted, and everything by all these charged particles. As it expands, at some point it becomes clear.
Opaque. It was opaque, and now it's
And at that point, the light can travel freely across the universe, and it has been doing that for 13.8 billion years, give or take.
Give or take.
And we see that light, and because the universe is stretched, those very high energy photons from that very hot early days have now been stretched out to the very cool microwave wavelengths, defined by a temperature of about 2.7 Kelvin.
Yes.
Neutrinos are these really bizarre subatomic
We love some
particles
neutrinos.
that are produced in atomic processes, high energy processes. Like if you have matter antimatter annihilation, you spit some neutrinos out. The sun is spitting neutrinos out. They come in a few different
Classic
flavors.
neutrino problems. And
Yeah, they're and they travel basically at the speed of light, but they have a little tiny mass. But the mass is so tiny that
they don't
it's
really
like,
interact with things.
and they're flying through all of us at
All the time.
a gajillion of them all the time, which means early in the universe they could fly through all that stuff before light could fly through stuff.
Sure.
Which means there's a cosmic, or there should be, a cosmic neutrino background that is neutrinos flying around since the time when the universe became transparent to neutrinos, which was earlier than the time it became transparent to light, because neutrinos are able to pass through stuff much more easily
Yeah,
than light.
how transparent, like how dense does it have to be for neutrinos to not pass through? Because like we detect neutrinos with this complex thing,
They
which we'll
hit-
talk about in a little bit.
Yeah, I mean they
Like
hit something.
there's some statistical probability that they'll hit
Right.
something, right? So it has to be
Right.
like really dense
Right.
for it to statistically.
I think Top Quark, Jim Cooney,
Would have a
who
better
will
answer.
be rejoining us next year, had
Sounds so long from now, but also so soon.
It's in a month and a half.
He gave us a trivia that was like, how much lead, how
Oh,
many,
I
like,
remember that trivia. I did
how,
so poorly.
how
on it.
long a slab of lead do you need to have a like 50% chance of absorbing a neutrino or something?
It was
And
big.
it was some crazy astronomically large number.
Yeah,
I don't
it was,
remember
like,
what it was.
bigger
It was
than
like a
Earth.
light year or something.
Yeah, yeah.
It was some crazy. Anyway, neutrinos can pass through stuff very easily.
Okay.
Okay,
There's
so
a trivia question somewhere in here.
the trivia question is, how old was the cosmic microwave background, the light from the Big Bang that we see is from much after the Big Bang, 380,000 years after. The cosmic neutrino background is from how long after the Big Bang?
So
And originally I was going
less
to...
than 380.
Less than
We have
380,000
an upper
years.
limit and a lower limit.
And I was going to give you... I've decided I will give you multiple choices.
Oh,
Great.
And the multiple
that.
choices are orders of magnitude.
perfect.
We're going to go nanosecond,
Okay.
microsecond,
Okay.
millisecond,
Okay.
second, minute, hour, week,
Oh,
month.
Oh, come on.
No.
It's too many.
Just all your normal,
Just all your orders of
all
magnitudes of time.
all your time units up to a century.
Okay.
So, month, year, decade, century at the upper limit, and down
So
to
100
nanosecond.
years. 100 years is the upper limit, and
Nanosecond
nanosecond
is
is the lower limit. Okay. Look at that. Look how narrow our time range is.
But and for the less than a second, it's just like nano, micro, milli.
Okay.
1 second, and then going up from that, it's orders of magnitude
Got
jumps.
it. Got it. Sure. Yeah. Really narrow parameter space here.
Yeah.
Oh, the list is like 8 choices or something. Come on, give me a break. I was going to make it just no information whatsoever, and this is the thanks I get.
This is basically the same as no information.
Yeah.
Really?
Yeah.
Because we already had 0 to 380 million.
Basically, it's
Thousand.
it's
Thousand,
whoever's
Well, I cut
closest.
it off at 100 years.
So that is the one
And-
useful bit
Just
of
means
information.
we'll be
in there.
wrong
By
by
an
a
order of
smaller
magnitude
amount.
at least.
You might still be wrong by a huge amount. You could still be wrong, obviously, by a huge orders of magnitude. So, why are we talking about neutrinos? One of our favorite places on the planet
Hawaii.
is Hawaii. One of our favorite other places for weird science experiments is
Antarctica.
Antarctica, and specifically the South Pole,
Yeah.
where there's this crazy neutrino observatory called IceCube, which is just a wonderful name.
It is. Also, it's a super cool looking thing.
Is it got a cool spelling, or is it actually just like
It's
spelled
spelled
like
Ice
IceCube?
Cube.
It's IceCube.
It's spelled
Yeah.
IceCube, and it's
It's one word.
actually very
Capital
appropriate
C cube.
because the instrument basically is a giant cube of ice.
Yes.
Okay.
Yeah.
It's a cubic kilometer
Whoa.
of ice.
Yeah. So they dug down underneath the ice in Antarctica and put some
Sensors
sensors
in there.
some photo
Yeah.
detectors.
Yeah, so it's just pretty cool. It's pretty freaking
you,
cool.
You
And
you
the building,
you look so excited.
The building up there,
It's so
looks
fun to
like
go
it
see
should
it.
be in a some kind of science fiction
It does.
movie.
It does look very science
Yeah.
fiction-y.
And so
Google.
the IceCube, as
click
Addie
on the
was
link
saying,
that I
they
posted.
drill down in. So you know how they drill with just heat.
Yeah.
And
Because it turns out ice.
Antarctica is, a thick slab.
Hannah
of
found out
ice.
that when she Googles
IceCube,
IceCube,
she
the
got a
first thing
different
that comes
IceCube.
up is the wrapper.
Yes.
Sorry, carry on. Tell me about the kilometre of ice.
So you've got all sorts of cubic kilometers of ice available to you down there below the surface at the South Pole. So you just drop your sensors into it.
Mm-hmm.
So the IceCube Observatory has 86 strings of detectors that have been drilled down using heat.
Mm-hmm.
And on each string there are 60
Little
devices,
I think they're like photodetectors,
detectors, yeah,
because we're looking for emitted light
correct.
that happens when the neutrinos interact
With
with ice.
With an ice,
And they cause a little photon.
yeah.
Mm-hmm.
And so there's like 4,000 or 5,000 of these detectors down there between 1.5 roughly and 2.5 kilometers beneath the surface.
Yeah.
There's this matrix
It's so fun.
of these detectors down there,
Sometime on the Walkabout road trip, we should go to Antarctica.
the South Pole.
Go to the South Pole.
That's a major expedition.
It would
Yeah.
be.
Yeah.
For a recording.
And they have they have
God.
some supplementary detectors at the top, and not all the detectors down there in the ice are identical. And the ice is, one of the cool things about it is that ice is so nice, yes, is so pure
Yeah.
that the light just goes through it.
Yep.
And so most neutrinos are just going through and not doing anything. A tiny fraction interacts with the nucleus of an atom in your water molecule, and it produces a muon, and then the muon does something complicated which produces a photon of bluish light, and the blue light travels through the ice and hits one of these detectors.
Yay.
And then that gets measured.
Yeah.
One of the crazy things about this is that the astrophysical targets that they're trying to see neutrinos from on this are not in the southern part of the sky.
So it's going through Earth.
Yes,
Cool.
they're in the
Yeah.
northern part of the
You've
sky.
got the biggest grin on your face with this entire
I
story.
know. It's so crazy.
So
Not that he has
because
a grin. It's the
Even-
experiment is
Yeah.
crazy.
even though you're 1 mile to 2 miles beneath the surface at the South Pole, cosmic rays interacting with the atmosphere above the South Pole produce
A crap ton
all sorts of stuff that produces all sorts of noise for
for
these
these
things.
detectors. Yeah. Are the detectors directed? Like the detectors directed toward the
No,
interior of
but
the Earth, or
somehow
can
the-
we tell what direction based on like which detectors it hits or something?
Somehow they can tell which direction things are coming from, and I
That's sort of
confess
vaguely.
that I didn't
Yeah.
really understand how that's done.
Yeah, because it seemed like there was some
But they have directionality.
So they have some directionality because they sort of think, to jump ahead a little bit, like we're going to talk about a certain detection, but they think it's from a certain source.
Yeah.
But there was somebody like that said, oh, well, it seems like it's from that source, but it could be from some other sort of general region in the sky or behind that source, right? So we know a general direction, but not
Yeah.
like a distance, I guess.
That's right.
So
we
it's
know
a
a
little-
direction. I don't totally understand how they know
exactly.
the direction.
Yeah.
And I'm not going to worry that I don't understand how.
I guess if
because
you have-
that's one of many things about how this works that I don't understand.
But like with a lot of like particle detectors, right? If you have multiple, you can get a direction if the if it's a
Yeah.
photon that's being emitted, it might just go to one detector.
Once you've detected your photon, that's it for that photon.
Yes.
And I don't.
No,
I
if
think
you
you.
predict-
I think you just kind of get it one photon.
Yeah,
per
but I guess if you
neutrino
statistically have a lot of
coming
them
from
coming from one certain direction, anyway.
somehow they can tell whether these things are coming from above or from below.
Okay.
And the ones they're interested in are coming from below, meaning through the entire planet Earth, except for the last mile.
That's pretty cool.
Where they run into these detectors. So why are we talking about it today besides it's a really cool place?
Just so Josh can have this big
Because-
window in
Yeah.
his face.
Yeah.
Because
there was a
they-
new article about
yeah,
it.
so part of the interest of this whole thing is that the cosmic so we've detected solar neutrinos.
Mm-hmm. Yeah.
In the trivia, by the way, we talked about the cosmic neutrino background has not been detected.
Yeah.
Ooh.
It is a testable prediction of the standard cosmological theory, but we have not seen those neutrinos. They're very low energy.
Yeah.
For
Oh.
the same sort of reason that the cosmic microwave background has
yeah.
been
Mhm.
stretched out to low energies. But there's this long-running question, big question about where do we get cosmic rays from?
Mm-hmm.
These are, many of them are protons that are accelerated to ridiculously high energies in some sort of thing that has got a generic name of cosmic accelerator, which gives these protons more than 1 million times more energy than we give protons at the Large
Hadron Collider.
in
Hadron
CERN.
Collider.
The
I never
LHC.
know how to pronounce it.
Yeah, just say LHC. It's safer.
LHC, the Large HC in Switzerland, accelerates protons very close to the speed of light. There are some cosmic accelerators out there in the universe that are accelerating protons to even higher, ridiculously high energies, so high that they escape the magnetic fields of their galaxies and travel across the universe. And we detect
And we can detect
them.
these. We can detect cosmic rays.
Yes.
High energy cosmic rays.
And we don't totally know, we're starting to get some hints like where are they coming from, but we don't really know what are these so-called cosmic accelerators. So just as LIGO is kind of like a new, you're not looking at light, you're looking at gravity waves. The neutrino
Era of
observatories,
astronomy.
it's like we're not looking at light, we're looking at these particles that have these very interesting properties. They're produced in very high energy events, and they don't get bent and moved around as much as cosmic ray particles. Even the high energy cosmic rays, because they're charged, get pushed
really
around
affected
by galactic magnetic fields and this kind of thing. But neutrinos are neutral, clue from the name.
So what's the story?
The story is they think they may have found a source for cosmic neutrinos.
Okay.
For this set of cosmic neutrinos that they're detecting.
They think they saw a 70 or something cosmic
This
neutrinos
is with the IceCube.
with IceCube, and because they have this directionality, they think they see them coming from a galaxy called M77, which is a Milky Way-ish like galaxy about 57 million light years away, so not at a huge distance.
Yeah.
But, as Addie was saying, we don't, even if it's coming from that direction.
And so to tie that into the cosmic rays, right? M77, if it's producing these neutrinos, is some sort of really crazy high energy environment, was probably also producing cosmic rays. So it could be a cosmic particle accelerator.
So that could be your cosmic accelerator. The wrinkle is that M77 is just a sort of very run-of-the-mill kind of place.
Yeah.
So if that's a cosmic accelerator, why isn't every other galaxy like that a cosmic accelerator? Which would say, how come we're not seeing these sorts of things from all sorts of other directions? So that's one issue. It's, the detection, of course, is crazy difficult.
Yeah, they in fact, for this detection, air quotes detection, but for this set of data, they looked at data that they looked at before, but they reanalyzed it with better, we've talked about other things like this, where you reanalyze data with better computational methods and machine learning and other things like that, and you get something out of it that's you didn't see before, and I know that's great, but they're also maybe we need better detectors and things like that.
I mean, we have obviously vastly oversimplified down to our level of understanding how the thing works. Is neutrino comes in, hits something, produces a photon. It's more complicated, right? So, but it's very interesting. But as Addie was mentioning, since neutrinos don't really interact with anything, this thing might have come from something 5 billion light years behind M77.
And some exotic, could be hiding
some exotic thing along that whole line
that
of
passed
sight.
straight through.
And just pass straight through, because as neutrinos do, as they do. So anyway, it's just cool. And they're talking about building a bigger IceCube.
Ooh, more detectors.
10 cubic kilometers of ice.
Oh wow.
We're running out of ice though, so
that's true.
It's
It's getting harder and harder.
There's right down there at the South Pole.
Maybe we can find it at the South Pole of the moon and build one there.
Do you know what we need?
There's not that much ice there.
I know.
It's also interesting though. We've talked about neutrino observatories in previous episodes, and some of those are they go to an abandoned mine, and then they flood it with a certain
mix of water,
something, and line the wall before they flood it. They line the walls of the cavern.
That's a good order.
They line the walls of the cavern with these detectors so that there's literally a big volume with detectors all around the outside. Then they flood it with a fluid that's got the highest cross section for neutrinos. And then they pick up those scintillations from that. This is completely different. IceCube is. And it's these like needles into the ice that are looking out
So fun.
into that cubic volume, and they're looking specifically in this case for the cosmic neutrinos, these very, very high energy neutrinos, unlike the sort of solar neutrinos that you would get from the sun.
Yay.
Anyway, speaking of neutrinos, then,
Oh, yeah.
how old was the universe when, assuming it exists, the cosmic neutrino background was produced?
My favorite prefix for units is microns. So I'm going
Okay.
to go a microsecond.
Microsecond.
I'm gonna go a minute.
You're going to go a minute. It's kind of right in between the two of you.
Let's go.
1 second.
Okay. Oh, that's boring.
1 second. I don't know. It's kind of, it's nice.
It's
poetic.
It's
It is
annoyingly
poetic.
neat.
Yeah, it's a little too neat. I don't
It
Yeah.
is very neat.
I
Yeah.
don't trust it.
It's well.
It
we
is what
haven't-
it is.
We haven't seen the cosmic neutrino
Exactly, because
background
we're looking
yet.
at the wrong time.
I'd say
I'm
it's
just kidding.
1,000 microseconds. How's
Ah,
that?
thanks.
That's right. So yeah, we'll have to. And there have been papers coming out recently that talk about new techniques that we might be able to detect these neutrinos.
That's fun.
And
Yeah,
that'll be
they're so
another
sneaky,
test.
those little neutrinos.
They are very sneaky, slippery.
Slippery neutrinos.
Slippery. And I was trying to understand about the mass, because like that'll be a fun
Yeah.
fact to tell everybody. It's like, what's the mass of a neutrino? They're so weird, and they are so small, and their mass is so small that I could not
Oh, get an
find
answer.
a number that made sense, because there isn't like a number. It had to do with neutrinos sharing masses between their different flavors, and they change flavors between tau and muon and electron neutrinos. And I was just like, I totally understand this, but I don't have time to explain it on
We
the
already don't
podcast.
know enough about
Yeah.
neutrinos. We'd suck at that answer.
Yeah. While it may have felt like counting neutrinos, it was just another episode of Walkabout the Galaxy. Give us 5 stars and we'll give you 5 trillion neutrinos. Be sure
There
to
you go.
follow us on Facebook and Instagram to get all our updates, and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel where you can see most of our episodes, some of our bloopers, and things are really happening. You have to believe me about the next music video.
Mm-hmm.
Catch up on old episodes.
I'll believe it
wherever
when I
you-
see it.
We're gonna. I mean, did I not just contact you about filming some B-roll for the
Did you?
music video?
Did you?
I did.
Is this a
Was I on that email?
I'm pretty sure. Said,
Okay.
can we all get together to shoot some stuff for the video before Hannah leaves? for
Anyway.
England? Catch up on old episodes wherever you get your podcasts. Follow us on Twitter, even though we have no blue check mark.
Oh, at walk_the_galaxy. We could pay for one now. So.
No.
And ask us questions at wtg@ucf.edu. Our theme music was composed by Richard Jurisic. Production assistance is provided by Logan Basinger. Thanks to our listeners in Decatur, Georgia.
Oh.
And around the world. Stay safe. I'm Josh Caldwell.
I'm Addie Dove.
And I'm Hannah Sargent.
We're the Astrocork, signing off until the next episode of Walkabout the Galaxy.
Oh, I'm supposed to say something.
Ta-ra.
Too late.